Okay, so let's start our first session. Okay, so this is about the getting started, okay, or just brief introduction about this our particular uh, OpenFOAM as a our driving force behind this training program. Okay, so let walk through certain slides. Okay, and it may be we try to explore certain ideas about OpenFOAM. We try to explore available applications and utility through this. Okay, so this is little bit let's say something like more than half an hour session. Okay, so let's go through this. Okay, so first let's start with the introduction about the OpenFOAM. So OpenFOAM stand for open source field operation and manipulations. Okay, so basically this OpenFOAM is nothing but some class of the operations and be able to manipulate the operations, and it is bundle of certain C++ classes and all these things. Okay, so like that way one can see what is exactly the OpenFOAM. Okay, so OpenFOAM is first and foremost a C++ library used to solve PDEs and ODEs. Okay, so it is a C++ library. Why we can say it is a library? Because when we go towards its different segment of coding, you will understand that different class of the coding is stored as a library. When we store something as a library, we need not to write it again, we need not to recreate it again, we just have to add up that library in our package and be able to customize our package, and we customize our need and try to simulate very quickly. Okay, so that's why it is in the library form. Okay, it come with the several ready to use or out of the box solvers. Okay, pre-processing utility and the post-processing utilities. So when we look at the OpenFOAM, it not come with only the basic structure of the programming, or it not only giving us the very basic platform, but along with that we also going to get certain solvers in terms of if we want to simulate the incompressible flow, certain solver is available. If we want to simulate compressible flow, certain solver is available, like that way. Along with that, utilities, pre-processing utility and post-processing utility. So in the CFD, if we want to execute any of the simulation or any of the analysis, there is a total 3 part. One is the pre-processing, solver and the post-processing. Okay, so for each of this part, OpenFOAM give us certain class of the facilities, so we try to explore later on. Okay, it come under the GNU license, so that means freely available and distribute with the source code. So what it means, that it is freely available. Okay, so we need not to pay. Here is the key advantage with the OpenFOAM. Okay, if you are aware, then if you go towards the industry, then all the commercial solvers charge huge. Okay, that means all the ANSYS products, Star CCM, COMSOL, everyone, if you aware or not aware, for single PC license it will cost something like more than 80 to 90 lakhs. Okay, so that is the normal package cost. But if we look at the costing of the OpenFOAM, it is free. But I not say it is a free, because OpenFOAM doesn't have a GUI, and it is very difficult for a very beginner very quickly start working with the OpenFOAM. You have a certain ideas then about the CFD and certain applications about the commercial solver and all these things, then it is very easy. But as a new beginner, it is not very quick. Okay, but then also we can say it is a very important aspect. It is freely available. Okay, it is basically a parallel computing environment. Okay, so that means each application, whatever is readily available, each one is directly hosted on parallel computing environment. So that is a beauty of OpenFOAM. Okay, another part is active development. That means every day, every year you will see new release. Along with that, in all the discussion form, like CFD Online is a very good platform to discuss and to explore very good concept about the OpenFOAM. Okay, and if you are facing any difficulty, you're not getting some solver, just Google it, and somebody in entire world, somebody did something. Okay, and you definitely, at least as a beginning point of view, will get some developed solver. So that is why I say it is in active development, and it is, if you see its capability, it's exactly mirrored to those of the all the commercial applications or the commercial solver available. Okay, so we can map directly whatever is available with commercial solver. You can find in different solver of the OpenFOAM, but it is not readily available. Maybe some aspect is available in one application, some aspect available in another application. So we have to adapt that aspect in the OpenFOAM environment and try to merge both the aspects from different application OpenFOAM and create our own new library or new solver. Okay, but capability is available. It counts with a wide spread of community around the world, like industry people, academia and research lab people, research student and researcher are actively working and developing certain new solver with the help of the OpenFOAM as a toolkit. Okay, so if you look at its capabilities, okay, so it is basically computational fluid dynamics solver, or I can say it is not only the CFD solver, but it is a multi-physics solver. Why? Because it has so many different class of physics involved, and it has a capability to solve certain class of the physics like heat transfer, conjugate heat transfer, combustion, chemical reaction, multi-phase flow, mass transfer, stress analysis, fluid structure interaction, particle methods, Lagrangian particle tracking, dynamic mesh movement, adaptive mesh refinement, aeroacoustic, electromagnetic, solid mechanics. Okay, so all these solvers or all these capabilities available with the OpenFOAM. Okay, but let's say we want, let's say, dynamic mesh movement with the heat transfer, so that part is not available. We have to merge both the solver and it's ready to go. Let's say multi-phase flow. Okay, and inside the multi-phase flow, let's say dynamic mesh movement is not available. We have to create new solver. Let's say we are working with the turbulent flow, but mesh adaptation or refinement is not readily available. We have to merge the product or merge the solver. Okay, aeroacoustic basic library is available. We want to create new, then we have to adapt certain equation, we have to code it. Okay, electromagnetic very basic solver is available, but electromagnetic with, let's say, compressible electromagnetic not available. We have to code it. So we have to merge the compressible flows solver with the help of the electromagnetic. Okay, so like that way certain things is available. Okay, but we cannot readily use out of box. Okay, like in the commercial solver, everything is available. Okay, if you are working with the COMSOL, electromagnetic, solid, you just have to click and all the models is activated. In the similar line here, you have to code it. You have to merge the two solver and create your own solver. Okay, so like that way it's going to work. So our objective behind this particular thing is something like this way. So we try to introduce you this OpenFOAM. Okay, that is the backbone of this entire training. By the end of the training, you may become out of the box user of the OpenFOAM. That is our hope. Okay, and that is our wish also. So we try to introduce you building blocks of OpenFOAM to help all the participants to become the user at a developer level. We don't see that you only become the user as like some commercial solver user, because please believe me, if you want to use OpenFOAM effectively, then you have to start developing your own solver, start developing your own utilities, start developing your own different type of boundary condition library and all this thing. Okay, then it is a fun to work with the OpenFOAM. Okay, don't try to use the OpenFOAM like a black box, like normally people working with the commercial solver. Okay, it is not the way we can look at as a OpenFOAM. But I want that all you at the end of this particular training, all you able to develop your own solvers. Okay, you should also be able to make simple modification to the OpenFOAM solver utilities and explore the source code to learn more about the libraries. Okay, so look, while this our basic training going on, okay, I will very quickly I give you the idea where is the source code and what different segment of the source code is important. Along with this, you have to spend your time and try to explore as much as you can explore, you get best out of it. Okay, so that is how it going to work. So what is the prerequisite I see is basic knowledge of CFD. If you have, that is very good. When I say basic knowledge of CFD, that means when we say okay, Navier-Stokes equation, immediately you realize what is Navier-Stokes equation. When we say, let's say, inlet condition, outlet conditions, when we say okay, let's say discretization methods like convective term, diffusion term, upwinding scheme, center difference scheme, all piezo simple algorithm, all this thing, if you aware about all this thing, then it is benefited. Okay, so I suggest you, if you are not aware, if you long back you studied all the CFD fundamental, all this thing, then I suggest try to read at least one CFD book along with this. Okay, and it will be benefited and you can pick up very quickly. Okay, then if you have a certain knowledge of scientific computing, that means when we talk about, let's say, this OpenFOAM in parallel computing and all this thing, at that point of time you have a little bit idea what is parallel computing, what is HPC and all this thing, but it's not mandatory. Okay, numerical scheme and all this thing, if you know, then it is very good and your learning curve is very, very fast. Okay, no prior knowledge of basic tool of OpenFOAM is required. If you don't know OpenFOAM, you are first time hearing OpenFOAM, no problem. All our training is like that way only. From the first tutorial onward, we will teach you step by step, and we try to give you the entire idea about entire directory structure, everything about the OpenFOAM. So if you never heard about OpenFOAM, you are encountering OpenFOAM first time, no worry, we make you in a comfortable zone. Okay, if you're not aware of the Linux, it's fine. If you're not aware about the C++, is also okay. Okay, but look, later on we want to talk about the programming mode and all this thing. At that point of time, if you have certain ideas about the programming, like what is the integer, what is the double, what is the let's say class, functions, template, okay, all this thing you have a little bit idea, then it will be benefited to debug the code, to understand the error and all this thing. Okay, so at the beginning level, for up to the programming level, if you don't have idea about the C++, no worry, because OpenFOAM code is a highly readable code. Okay, for that, reading that code of OpenFOAM, no understanding or no big understanding of C++ is required. Okay, so when we walk through, you understand that thing. Okay, use live USB drive only for entire of this training. Okay, so what I am saying is that right now don't use your own installed version of OpenFOAM from your laptop or your desktop. Okay, I suggesting please use this live USB, because on the live USB we burn couple of few more utilities that may be useful for certain class of the tutorials. Okay, so we not going to talk too much about this programming and as well as theory, as well as Linux administration issues. Okay, so we try to minimize all this thing, and we not going to spend our time or waste our time on all these things. Okay, what we want from your side, please ask the questions. Okay, help us to understand what you are missing, because look, if I giving you the classroom teaching immediately based on your expression, I understand are you able to getting it or not, but right now I'm not able to see your face. Okay, so it is very difficult for me to judge or that are you getting the things or not, or you are facing any difficulty or not. Okay, so please give us the idea if we are going fast, going slow, our teaching style you are not able to adapt. Okay, what are the tutorial we are providing, it not going it not working for you, you are not able to familiar with certain command in the Linux. We try to give you the certain more reading, and with the help of that you clear all that hurdles. Okay, we have a certain manuals. Okay, so I will give you that a very simple command manual for Linux command and all this thing. Okay, so it will give you the idea how to work with the Linux, what different command useful and all this thing. Okay, try to put more questions. Okay, why I'm saying, because everyone is working with different mindsets, so your question may be benefited for others. Okay, so try to raise the question and we try to clear all the question. If you're not able to follow us, please stop us. Okay, if you not understand, let us know. That is what I want from your side. Okay, so very important aspect with the OpenFOAM, it come with the two document. It is very, very powerful document, I say. Okay, user guide and programming guide. Okay, and I suggest try to digest carefully all information contained in this two particular manual. Okay, so I will show you from where you get it. Okay, so it is a very, very too powerful manual, so please go through entire of this manual. Maybe user guide is cover of something like 250 page or something like 300 page. It's very simple, but it give you the brief idea. Same way programming guide is very, very important. When we go to our programming mode, it also possesses something like 300 pages or so, and it is cover very, very fundamental aspect of the OpenFOAM. Okay, so entire this training, if you see, or if when we walk through entire training, you will understand most of the things I adapted from this user guide, programmer guide, and the training provided by others. Okay, so I constructed couple of the tutorials based on the tutorial available in the Google, readily available. I modified, I clubbed couple of tutorials from different trainers based on my understanding of OpenFOAM, and I feel different trainer has a different way of approaching the OpenFOAM. My approach is maybe completely different or little bit different with the others. Okay, I believe in something like this way, entirely hands-on. Okay, because the way I learned the OpenFOAM, I am expecting that it is the best way to learn the OpenFOAM. That means if I speak and you just listen, it is not going to work. Okay, only minimum speaking and maximum working, it is the way to go with the OpenFOAM. Okay, because it is not like a simple CFD course or some training where you only have to listen and go through these slides. No, here maximum time we're going to spend on running different type of the tutorial. As we run more type of the tutorial, you will come to know different capability of OpenFOAM. Okay, so basic idea about this training, you supposed to aware what entire capability OpenFOAM possess. Okay, and where to look that capability, where to adapt that capability, where to find that proper tutorial, where to find that proper boundary condition, and combine all this knowledge and apply to your own project. Okay, so if you want the best output, I suggest try to formulate very simple project. Okay, and immediately start applying all this concept to your project, and parallelly you can learn. Because look, tutorial is at a one place, but until unless you apply this knowledge to any one of the particular problem statement or any of the particular project, it's not going to give you the fruitful result. Okay, later on you may lose the track and you forget all the command. Okay, better immediately start applying all this knowledge on some class of the problem. Okay, this is very important. Take some time to explore the source code because it is available with you. Okay, so entire source code is available. Okay, so it is not like a black box. You have each and every command line, everything is available. So try to explore. Okay, so how to get best out of this training? Read the user and programmer guide. Okay, explore the source code and Doxygen document. I will quickly give you the idea later on what is Doxygen. So Doxygen is the documentation of entire source code. Okay, so you need not to walk through your like conventional way of looking the different file, but with the help of this Doxygen, you can click one file, and whatever the file is linked with the Doxygen, immediately you can access all the files. So later on we explore this part, but Doxygen is the way to look at entire source code. Okay, get familiar with all the application utility available by doing all the tutorial available in the OpenFOAM installed version. What it means, when you install the OpenFOAM or whatever the OpenFOAM install in this pen drive, it also have a certain more tutorials. Okay, that is readily available with the OpenFOAM installed version. So I suggest along with this tutorial whatever I am giving you, out of that also couple of tutorial I adapting from this distributed version, but I modify based on my requirement. Okay, but I suggest try to look at all the different class of the tutorial available in OpenFOAM. I think more than 200 tutorial is available with the OpenFOAM. Okay, so try to look at that. We also provide you many more tutorial, okay, which are different from this that come with the install version. Try to go through each one of these and get familiar with entire OpenFOAM environment. Okay, when we going to execute our tutorial, there is a readme file. Okay, it will help you to run the case. And please understand, don't use any of this tutorial for validation and benchmarking purpose. Okay, but if you want to develop a validation and benchmarking way of any of the project, try to adapt this tutorial and try to customize the boundary conditions, tune your grid or mesh generation accordingly, and it will facilitate the benchmarking or validation prospect. But if you want straight away adapt, let's say lead driven cavity, what we're going to solve today, and you hoping that I can immediately compare this result with the published data, then maybe it's not going to work straight away. Why? Because here we going to look at very basic meshing. Okay, not a very grid independent type of the tutorial it is. Okay, so when we go towards some validation benchmarking, we require certain sophistications. Okay, later on I will explain you how you exactly approach the validation and benchmarking. Okay, so you have to have to follow certain steps in this regard, but we are just exploring tutorials, so please don't use this tutorial straight away for validation and benchmarking. Okay, learn from OpenFOAM case or course tutorials. Try to change the case and study the outcome. What is case? That means whatever the tutorial we are running, it is called the case directory. Try to change certain thing and look at the output. Introduce error in the case and try to understand OpenFOAM output. We going to explore that part. We going to give you certain tutorial where we explicitly created some error. Then you have to remove that error by changing certain things in the case directory. Make totally different case using the same solver. Like when I say make different case totally, what it means in during this, let's say we are using for the first tutorial, let's say simple form and late driven cavity flow tutorial is available. Okay, I suggest adopt that tutorial and let's say create your own tutorial like a flow or a backward facing step for very simplified Reynolds number. So like that way you create your own tutorial with the by adapting the whatever is available. Okay, learn C++ is extremely benefited. Learn Pythons, and Python is the scripting language. Okay, and maybe it is useful for some specialized data analysis purpose. Understand the solver. That means don't use like a black box type of the things. Okay, whenever you are using any of the solver, try to read what the solver is for. Okay, so I will give you the brief idea how you going to do that. Okay, top level programming, make your own solver or modify an existing one and step by step create your own solvers. That is how one has to adapt the OpenFOAM. Don't just try to use like a application point of view. Okay, understand the theory behind everything. That means if you are not aware about the different class of discretization method, please try to rephrase or rebrush all your fundamentals. You are not aware about, let's say, algorithms. Okay, please try to look at all this aspect. Okay, it will help you to understand few things. Okay, some useful links for that. User manual is available. Doxygen manual is available with this link. Okay, CFD online discussion forum is the perfect place to look at certain things. Okay, OpenFOAM wiki, openfoam.com, and extended project. This is the very important link from where you going to get so many resources or so many data, so many solvers, so many tutorials, so many things you're going to adopt from this particular place. So I suggest please try to look at all this aspect. Okay, so this is very brief idea about this particular OpenFOAM aspect. Okay, so let me go